ओके से हॉर्स thermal properties of matter da khoi wal howa topic macha am khatang khoi togi ge radiation gi pata when's displacement low haidana so adom dang thau when's displacement low ngarang newton's law of cooling ta me yengo khoi thermal gi da thermal properties of matter da thermal properties of matter da important oiriba topic number 1 thermal expansion. Then next, finding temperature at a point. Road ma piri haraga point nama the temperature putoba. Se koi taura ba taudriba. Taura ko ja good. Same road tugi point nama ha pe ai. Natre haraga se road ani connect to sale. Adu na kisi junction do the my temperature kaya no. Sumai na hangak pa ma. Now next, sina conduction gi pani radiation gi pata. Radiation gi path ni ko when's displacement low han lag to isi radiation gi da koina hot body am le re body am khak le re ma gi temperature je t hai re ji heat emit to do ni every object at a given temperature emits radiation any temperature double le re di temperature high hoigera low hoigera any temperature amada le rava of the body duna ka done ba heat emit to ne yandara was heat emit to do ni this is your heat emitted. Heat to has a radiation heat emitted radiation heat in the form of radiation. Convection conduction nangi touch tawrakan da ingora sawa phaurakani heat transfer to win that is conduction nungsit ka silla kanda natraga ising amakak chenagi ising na sida sai salurakan da sida leire nagi achin ba ising durana na asaba object thamuradi makha tarakpa swaida leiba ising ling sagalak droja by convection akoina hojung nai nai se kaino radiation medium am the yaud vida so radiation gi oinadi any object at a given temperature heat emit tawni haba odi surrounding is temperature habam lemani dana surrounding the sena gi t note ko temperature am adi mana jo heat emit tawni harmen ma jo heat emit tawsaloidra so body amana tawdu se kaino radiation gi ni ko nai nai ja radiated su tawni ado nagi absorb su tawni mabani gi net tu ne ba koina count tawdu se now yare radiate tawri basigi heat से radiation हर electromagnetic wave ni electromagnetic wave और my wavelength पुथोक पे यानी so radiation emitted सी temperature body amana radiate tawri ba sigi emit tawri ba radiation जे मागी wavelength maximum wavelength the lambda maximum जे कहीं ना कोई explain तो रखी है is inversely proportional to temperature है yung radiation emit tawba kanda ne particular wavelength ama khakta da emit tawdaw nate whole spectrum emit tawrakane ajina gi sida puthorok to radiation to gi magi different sena gi color rom da har kana blue zu yarongani red zu yarongani green zu yarongani lambda maximum highway adadi the wavelength of the radiation which corresponds to the maximum nagi emitted energy do say suppose 100 joule energy emit tawren khalaji sigi ashaba object sidagi in the form of radiation da 100 joules ida yaw do se nagi green color yaw ni blue yaw pi red yaw pi karamba color do corresponding to which color do na maximum energy nagi emitted to contribute to the do uniform oiro eba se green blue red aduga amana kari haji yellow haraji color mari khaglo gi example gi line na makoi mari gi apun baduni 100 joule haiji adu equally distribute tawre haga 25 adu natte yanda kadra particular color particular radiation amana main contribute tawne ba say for example blue hairo blue sin 95 ko oiraga atai lem ho buduna atai map ji yena doine so maximum the contribute tawriba radiation do adugi wavelength ne khona lambda maximum haiji mayam sida khwaide wavelength saw haimana te ko ja lambda maximum kai have a wavelength of that radiation of that path of the radiation which contribute most temperature inversely proportional oini have so when the displacement low end of the tharo whence displacement low, whence displacement low na haise gaino hargadi lambda maximum is inversely proportional to t, where haraga so implies haraga lambda maximum equals to hadi kai tane haro constant am habo idra, so constant do koina b hen lowi, very simple relation where harakanda lambda maximum haibaje maximum wavelength haibana tre kari haido bharo wavelength of the radiation which contributes majorly in the emitted emitted heat to the ख्वाइदगी साउना नगी contribute तौरिबा radiation दुगी wavelength सिना ताइसे कनो दुदे body दुगी temperature साउखलिंग खाई wavelength of the radiation which contributes the maximum को ये से energy दो कदोने हबा temperature साउन के wavelength पिक थरक तौबा याम चंबा example सुमाम ता हाये object अमखक से iron अमखक ना heat तौरे अहान भाई heat तौगान माई color से करी वाली हारो red color ओरमनी हेन सुम नंगी heat तौसुल ताड़े के वाली हारो येलो कलर देन नंगी ग्रीन कलर को लानी नेक्स्ट ब्लू को वरानी और एन क्वाई सावा जी वो कोई क्या है व्हाइट हॉट व्हाइट कलर को वरके ने अब हम सारा कांदा से गैस स्टेम नंगी फ्रेम दजु दूंगा गैस फ्रेम दजु करम कलर नो कोई ना गैस फ्रेम दो उरी से सिंग ना मई तो सिंग ना साग थोंगा दे सिंगी से मैं सिंग साग पर कांदा माई कलर से कई कलर ओए येलो गुंबा रेड गुंबा ओइड्रो गैस दी blue green blue mai orakro sa why mai se ngasage nangi sak pa kanda temperature se karam mano chaw helam do se sing gi duga gas ki na temperature saukhling khai temperature sauring khai high river nangi temperature sakhola kanda puthori ba radiation do of the main contribute to river light to radiation do gi wavelength kai do ne ba pik thagi ne ba sina temperature pik pani aduna red kumba yellow kumba color hadi puthore radiation du adu moi wavelength sing sigai do hero sakholak tro sa wavelength sawina tro red na khwai sawda ina nangi visual da temperature sum sawring khai color do wavelength apik parom da sat khine ba ano kadom da sakhini blue da green da sakhini ha ano sa do gore sa when's displacement logi kana vana advantage na kaino hargadi it is used to predict the temperature of a celestial body से नंगे सन की ओबे याय मून की ओबे याय जस्ट मागी कलर डू येंगे हर कांदा से एग्जांपल की होइना दिस इज द सरफेस ऑफ द मून अमजर नंगे सन हारो सन दगी लाक पर लाइट मयाम सिंग दो अब देखो ये मरु होइना करम कलर द कोइन उगे दो माई कलर डू मखंगनी कलर डूगी अकॉर्डिंग माई वेवलेंथ पुतो को यारनी स्माइन तो दना था दगी सु मून दगी सु लाइव नंगे लाइट तो अदुगी मागी wavelength करम हेना contribute तवी अखोय दु पुथोक यारनी just by knowing this wavelength सिखंगा मतुंगदा we can predict the temperature of this moon ne yandaraba 100% accuracy oiro adu predict तव यारनी so सिजमा खंगजलो सिगे खोय relation graph amते यक्से lambda maximum का temperature का ग्राफ थियो lambda maximum का temperature का ग्राम ये दी lambda maximum and the temperature of the body, what will be the nature of the graph? Kari graph male se see the y equals to bj define to what is this b when's constant is some constant amani y hypothesis some constant times divided by t to the x if araba see the x y equals to constant atro kari se to line haro je haro rectangular hyperbola so the it is this graph hayeng mana sige graph ye ohd frequency ke graph ye ohd kamai to mu maximum ke graph ye ohd aduga temperature body amagi temperature man emit tawriba radiation dugi frequency mu maximum. Noi lek ya phangdaw yaw basida. Yeah. What will be the graph haro dudi? Lambda maximum ga T graph lai re sirana gi mu maximum ga T graph. Kari graph hoy do na sina. Predict tawro. Equation se lai re. Ai hojik radiation nainari mi radiation naina kanda di energy wavelength ga nagi frequency ga what is the relation haro? Wavelength have the mana distance and relation speed into time gi inverse na through frequency hai. So speed to the speed of light on arrow radiation in a other question relation se kama arrow yani haro as lambda maximum haivazi d by t oiramina lambda maximum ki mota hui kai ive abharo speed divided by mu equals to b by t ve arava cd implies haraga mu maximum cd kama ive are c by b times t. C is in a speed of light, b is in a wavelength constant. Constant ata na droja. Adi cd kari form the live haro y equals to mx. Sige form the laitro. So y equals to mx had a graph kai tane haro straight line passing through origin. Straight line board is slope discussed over kaugano. What is the slope haro? C by t. C is in a speed of light. B is in a Wayne's constant. Thangza losi ki graph se kya hai? Now see relation macha se the numerical question macha am tang hoche. Adu ke yarani. Radiation ke khoi swade halas. So radiation ki pa ta koi topic ani tawre ngarang na Newton's law of cooling ngasi nagari Wayne's displacement law. Yarabo. So the yauriba lambda maximum se kaine ba wavelength of that radiation of that part of the radiation which contributes mainly in the radiated heat. Yandarabo. Radiated heat main contribute tawriba adum radiation dugi wavelength ni lambda maximum wavelength mayam gi maximum high bana te ko ja yarabo graph ek pa hero atoba graph ta ye ki se cho yarabo sumba graph khar ye le mana nangi si intensity ni some nangi intensity of the radiation intensity of radiated heat to ginagi intensity mana sumba graph khara period sumain tawdana sisina t1 hairo sinangi t2 hairo t1 ya t2 kanan sawi hanga de kamai taw intensity radiated intensity or heat to gi quite the main contribute tawriba na gi light wavelength radiation gi wavelength do na to kena lambda maximum hai do so this is lambda maximum of 2 sisina kai point kawre the maximum energy t2 gi corresponding mathak thangbasi gi maximum du sina troja ani subai maximum sila rava adu sigi corresponding wavelength lambda maximum for this one coin hagre lambda maximum haiwasi t the inversely proportionate oi haraba lambda maximum chawring hai t ke do ba pick to ba adu lambda maximum ani se kanan chaw helino lambda maximum ani se kanan chaw helino one chaw helino tra me wavelength line ne basi since lambda maximum 1 is greater than lambda maximum 2 of the lambda showering temperature ke do haro pick over so t1 is less than t2 as karigino lambda maximum haivazi inversely proportional to temperature as lambda maximum is inversely proportional to temperature yaad raha Good. सिबो याल है. Now question करा हो चीज़. ऐसे हम देखते हैं तो रखे. Na grab ahung khage radiation के दा. सिमा हाइज़लो. Next question ani ahung का हो ची. Question हम खगे uses इधर. Question style हम खग. A piece of iron is heated in a flame. Frame the iron se hit tawre. If at first ahan bada it becomes dull red. It becomes dull red. Then then reddish color, yellow, and finally turns to white hot. Turns to white hot. This can be explained by karamba law na no explain to this. This can be explained by Roman number 1, Stephen's law. Roman number 2, Wend's displacement law. Roman number 3, Newton's law of cooling. So last none of the above. Haro, sumba question हम हंगादी. The color change so give do temperature sum hangalaga. Temperature hangalakan the body dugi nagi colors e kadom the shift away the adu hangover. Kadom the shift awani wavelength sum pick thagi temperature hangaladi. Yarava temperature hangalakan the wavelength apik from the sang hidover. Aham bada kaidorame red ngali ngali tora me then gangsang ngange yellow ere then finally turns white hot. Yandarava. And see me am saying when temperature changes, the heat token the temperature change token the wavelength sum pick the easy. Kari phenomenon kanan explain to ni haro Wend's displacement law. Yar was next question. Yam chami ko ja very simple. Question ani khaka ho thi ge sida base over. Three stars A, B, and C have surface temperature TA, TB, and TC respectively. Star A appears bluish. Star A do blue color gumna blue harap change haba. Star B reddish amasina ngangya and star C yellowish. Then harakanda Roman number A nangi wavelength sing do wavelength of the temperature nahi no. Then which one is the hottest? Is mahar guess. Which star is the hottest? Why the gis hagada banangi star do karamba oigada gi harava A B C haro. Sumba question hangadi. Star ahum laire. Surface temperature TA TV TC ni. Star A se na kari color neva blue hai. B na red, C na yellow. The karambas star nova here na quite haram do is. Electromagnetic spectrum the mana P is a video direct dum erase. GYOR. By winds displacement law na kari haire body dugis temperature handling khai magi wavelength of the radiation which contributes nangi measurely hatare adu wavelength handhani have natro main contribute toriba radiation ki wavelength handarni adu neba haire ba koina udoi ju main when contribute to udu natro udoi sa star a gi na kari color neba blue star a gi ni se for star a next amaduna rate sina nangi star B amanagari star C. The current temperature south is haro by winds displacement lambda maximum contribute taurido ne bakon udo is B 1 by T. T the inversely proportional we hydro wavelength P ingai temperature saure. So star with nangi minimum lambda maximum ngau brase minimum harga lambda maximum harga now so minimum lambda maximum will have maximum gari T maximum since lambda of kanano quite P is blue is minimum so star A has maximum temperature. So the T do kana quite sounding haro. Finally, what is the order? Temperature you order do? Quite sound si B, mathanda kana C, mathanda A. This is the order of the temperature. Janta how process? Yagadro. Chumiko. Good. Last question for this. Last question say Sigi part Sigi. Then we will jump to kinetic theory of gas. If wavelength of maximum intensity of radiation emitted by sun and the moon are 0.5 into 10 to the power minus 6 meter and 10 to the power 4 meter respectively. Find the ratio of their temperature. Find the ratio of their temperature. Temperature की ratio पुतो है. Am I पुतो कनी? Wavelength of the maximum intensity of radiation do the radiation which contributes nangi maximum ko adugi wavelength makhagi pire nangi sun na emit tawba ma moon na emit tawba ma given the lambda maximum of sun numit ki c value kya ne have 0.5 into 10 to the power minus 6 meter and lambda maximum of moon equals to nate onare man man oh yare oh oh moi pau di phau na de ga I want the number am ta laite. Ha ha. Okay are. Now lambda maximum mun क्या ने हवामान 10 to the power 4 meter यार बस यहाँ good सी खंगो मतुंग द temperature की ratio नहीं नो है ना त्रो since lambda maximum हाइवजी inversely proportional to temperature ओइ बनी ना of the temperature की ratio नहीं नो है मिनट temperature of the sun divided by temperature of the moon क्या तादो माले हरो inverse order में ना lambda maximum sun दोनों मखा जखी रोइद्रो lambda maximum of sun sina lambda maximum of moon क्या ताने हरो moon की lambda दे क्या नो 10 to the power 4 अम्मा सिना 0.5 into 10 to the power minus 6 क्या हम खेना करेंगे obviously खेना ताम नहीं ना compare to जो खेतन compare to वो यावा compare to the फैदा होगा in way यारे incomparable 10 to the power 4 गसी के 10 to the power 10 तारवा सीधी नंगी 10 by 5.5 तो मतलब 10 हर चलो क्या तारे सीधी 2 into 10 to the power 5 10 to the power 10 यार उधर से so this is the ratio sin hiding is again no temperature of the sun is 2 into 10 to the power 10 times temperature of the moon हम साथी खेने को जा चलो चलो so next topic में थारो kinetic theory of gas kinetic theory of gas so थारो kinetic theory of gas kinetic theory da khoi topic ani mainly khoi focus tawni number 1 nangi vrms speed puthokpa ko rms speed puthokpa number 2 nangi maxwell say equipartition energy nangi maxwell law ani si da khoi focus tawni so tharo topic kinetic theory of gas kinetic theory of gas yung ay noy da assignment am pige yung da salo तो kinetic theory of gas से आई लेक तो वगैरह में वगैरह any book ता आहान बता यार हम तो इसे assumption है ना kinetic theory of gas अदुमा हर point मचा अनि हम इचल था मगो जा assignment boy ददुम इथो now अखोई कितंग समय हरगा यो kinetic theory of gas की assumption दा अते क्या मते हैं ideal gas की assumption दो चल माने कहाँ निको जा आहान बता topic थारो RMS speed of gas RMS speed of gas मा ये formula V RMS C करेगा माना गया है root over 3 P by rho derivation तौबा कांदा और ईवा कांदा pressure ये form दगे derive टाउ नहीं तो कोई ना हाइग्रे kinetic theory of gas असी नरीजे ideal gas में अब ideal gas अदी P by rho जी करेगा माना गया high D root over 3 3 RT by M root over 3 RT by M नी सीधे यार इबा P जी गई नो pressure then again सीधे ना यार इबा rho से ना करी density R जी दी universal gas constant whose value is 8.314 joule per Kelvin kg a mole तो बोलो PV equals to nRT PV से joule ले रहे हैं आगे number of moles and temperature चुम्मी को जा good next m से नगरी molecular mass ये सीधा mamang da khoi na mamang da na tre na khoi tam graba wave tam graba khoi VRMS akhoi na sira nai nai se RMS speed of gas ne ba da khoi na RMS speed of sound ani se confuse pe adi in air da sound की speed से शी करीगा मान लगे है कहता VRMS of the sound ऐसे RMS इधर इधर V sound तंग समझेंगे it is nothing but gamma RT by M ओइने where gamma से कहनो नगे specific heat constant में आमगे ratio which is नगे CP by CV दो यान दागरो से हम so formula ani se confuse करनो सिना 3 ni सिना gamma ni ani se kanan चाव हेंगनी हरो ani se kanan चाव हेंगनी RMS speed of the sound in air ga RMS speed of the gas to ga kanan chaw hengani amana gamma ne gamma value je 1 ga 2 ga merak ta leibani ama je nakhe je 3 na tro so the V RMS of gas is greater than V RMS of sound in a gas una medium ni sound travel tawriba medium gas na gas to gi nangi speed to na chaw heli yarabo because amana 3 ni amana gamma lies between 1 and 2 very simple formula sida question yam hange so let's start solving problem point amana even though it is expressible in the form of pressure both this BRMS of sound hagera natraga BRMS of gas hagera they are independent of pressure VRMS is independent of pressure kaun ko sima even though pressure da is a razu if the pressure you form the evasu yaidana P by rho hydro even though it can be expressed in form of pressure it is independent of pressure never अब the VRMS से कना खत्ता द depend हो रहे हरो only on Roman number 1 temperature and Roman number 2 gas type of gas oxygen la hydrogen la adu da depend हो रहे हैं clear हो गया good now what the what power is booklet तो ये what कैसे page number 47 page number 47 question number 28 दिखते हैं तुम सी ना तुम हायर ratio of RMS speed of an ideal gas at a pressure P to that at a pressure 2P है amana pressure P amana 2P atay दिमाग कहीं पंदे देना कहीं 15 दी नगे temperature constant in loro और that pressure फनेयाम change तो रजू temperature होंगे दी अपन hydro V RMS is independent of कहीं हवा pressure so pressure खेलना रजू speed ये तुम कहीं तो ही ना हवा same होगी नहीं so the answer should be 1:1 या out of option 1:1 अब तो खोजल यार हवा 1:1 even though the pressure changes as long as temperature remains constant BRMS will be same ni so the answer will be 1:1 या कर रहे चलो next question number 22 page number 47 of the revision booklet the molecules of a given mass of a gas have root mean square speeds of 100 meter per second at 27 degrees Celsius and 1 atmospheric pressure चल गया रहा okay ला sagat pro okay ला hostel laibra yum de laira library da चल il asomde okay यार So the molecules of a given mass of a gas have a root mean square speed of 100 meter per second at 27 degrees Celsius. 27 the 100 meter per second ni aduga 1 atmospheric pressure jo pire. What will be the root mean square speed of the molecule of the gas at 127 degrees Celsius and 2 atmospheric pressure habra? Mana sida pressure p river pressure je nangi useless ne aba. We are not going to use this. Extra information pishan bewani. BRMS akoy pressure de depend tawi ha bro. Taw deba. BRMS depends only on the temperature in the gas. Ade kamay hot kani? VRMS of the gas to. Formula kay no haro? Root over 3RT by M na dro. Now adu di haro? VRMS of gas root over 3RT by M. Adagi ngasay na idaba ma TC kay doon ka daba haro? Temperature in Kelvin. Delta T dadi Celsius Kelvin sa manayaba. T dang yawra madi Kelvin do on do. Kauno ko sema. Now hara jadu then haraga V2 by V1 to isan jeje compare tawdo ni. Adi ani suba condition ki velocity ahanba condition ki velocity. Adi ratio nahi na kan the root over hara lawadra. 3 manare R manare. T na trozo khena isa. M manavra manadabra haro. Different gas lo na traga same gas lo compare tawdo isa. Same gas. Adi M dozo loy kakrava. Lasa kay tahawne do dia T2 by T1 since nangi type of the gas is still same. T2 do kaya nen piba mana ani suba condition gido 127 हमने थ्रो 127 इरडी लाले कई वन इधो भरो केल्विन दा 127 do क्या ताने हरो 400 Kelvin. Next T1 do no क्या नो हरो 27 हडी 300. Have the T1 have the appear is 27 degrees Celsius which is 300 Kelvin. T2 high baduna 127 degrees Celsius which is 400 Kelvin. क्या करो से good. अब देखिए क्या तार है root 4 by 3 root 4 by 3 तार है root 4 to the 2 तार है so 2 by root 3 ratio नहीं know how many this is the ratio. Okay my ratio ahan by the p rimani को value अब v2 क्या तार है रो दी twice v1 by root 3 v1 दी क्या नो 100 divided by root 3 divided by root 3 root 3 is 1.7 something तादा नहीं of the option the है खल रोजे 200 by root 3 200 by root 3 meter per second. So this answer. Question number 23. Question number 23. Try करो. Question number 20. At 0 degrees Celsius temperature, root mean square speed of which of the following gas will be maximum? 0 degrees Celsius हमें temperature constant in pirava. Temperature आना BRMS habisi kanade depend to baharo 3RT by temperature to low na magi 0 degree ni harava. 0 degrees Celsius means 273 Kelvin. Yan tagadra? Awi tagadi that is at the same temperature VRMS habisi kanada inversely proportional over 1 by m da. Habidi molar mass molecular magi weight molecular mass hundringai p inkai b saudu natra. So that is VRMS will be maximum for minimum m minimum molecular mass. The molecular mass quite peak was kanano haro. Man p reaching to the quite peak was kano haro that is hydrogen. Very simple. Numerical हम तो हो से question number 24. Practice हम तो तौरोज. Exam की नहीं खलो. Exam की नहीं खलो. हंदक मंदेदा thermal gi test legeni ko na khoi gi test for coming Monday will be syllabus 2 thermal physics. Thermal physics study thermal properties of matter, then koi thermodynamics aduga sigi kinetic theory of gas. Yaraba ngasina dum koi kinetic theory of gas lotion ba yani tawda bo koi topic khar chethana da wa hayeng yengaji so hayeng dagi anoba topic ma tak class pung timing khar sangdue noi khange ko khangan jaro na sana 9:30 dagi koi 11 so I bo conduct tours class like tram si dai da next let's see question number 24 let's practice this question holo si loi phange ko hojik yelama ba yendri ba select pidri ba the pela now say question number 24 practice hoji yaw bom kai practice tawba horo try tawba horo numerical value ama khangi da exact puthokpa yaroi aduna answer du dagi akoi approximate value ama lawduni so noi online da kai da yengi ba satra makai booklet lawda targa di ko adu da lawsalo lako farak taraka noi friend gi through dagi lawro kemi ama khak yengi mane okay YouTube ta kya yengi how many okay ai yengi ko YouTube ta say yare question number 24 try toro try question number 24 RMS speed of oxygen molecule in a gas at 27 degrees Celsius would be given by RMS speed hydrosigo VRMS sida noina soige da bakhar leiri same do ose bazi temperature से हरो temperature से क्या अनुमान पीरीज है 27 डिग्री सेल्सियस केल्विन दे क्या आता है 300 केल्विन R की वैल्यू दी क्या नो 8.314 जूल पर नंगी केल्विन अदुगा सीधा मोल जूल पर मोल केल्विन then what about molar mass ऑक्सीजन ये ना तो पीरीज है क्या आता है हरो ऑक्सीजन molecules नहीं O2 molecule hydro section का दबा O2 ओडी क्या आता है O गिरी 16 नेक्स्ट ऑक्सीजन गिरी 16 नेत्रो अतो अनी सुरमिना 32 32 से करी नो बजी 32 एक तो ई आर रबा याद है 32 से केनो ग्राम यंदा रबा 32 दको ग्राम इद्रो so it is 32 gram नेबा सिसिना नेबा 32 सिनबा कांदा ग्राम दुदी याद रेबा मी अतैना एसा द लोई इरे सिदे एसा नत्रेदना अदे कई द ओंतोकम दका ओए 10 to the power minus 3 kg सिनै चेक तौदसी यारे दुदी होलो देन दो इतरगदी VRMS क्या ताने हरो 3 into 8.314 into temperature d 300 divided by 32 in the power minus 3 क्या था दो मालूम zero सिंह से हानम तो लंगथोक्सी अदो गेस तो वो नुआई ना मैम the answer the period 4.9 point याम पिंग people जाओ अनि यमना 483 966 कितना द्रो यामना कमाई तो उसी क्या खादो वसीरा 3 into 8.314 divided by 32 into say 3 m 339 0 से 9 into 10 to the power क्या नो सी 3 से 9 point रेको जा 2 अमगा सी कदी क्या बोले 5 5 ताद्रो से 5 0 अनि लाना बो होना सी अदai सुमाई तोगे सिदगी 0 अनि 4 है पुथोखरो 4 है लागता दे होरेन लास्ट 100 हाइबा म लानेबा 100 हाइबा म लाखि तारगदी सिदे यावरिबा 4.9 पॉइंट यागिद्रो सिबो यार रोय ऑप्शन सी एंड डी इज wrong not possible अदे हारो so c nagi 100 10 to the power 4 dagi 100 chongthole 100 lem ho buduna 9 into 83.14 la lo divided by 32 sida tarak toido yengazi harap approximately 9 sida ka di 9 4 is 36 harap jomai tadra saholini 4 na sida kya tarni 4 na sida 20 ga 1 ga harone root 21 tadro sa root 21 tadoram neva the root 21 have is keno see the 4 tadoro 5 tadoro amana mana 9 na to lies ya option number a the p is in a 483 b giduna 966 karam mano hayang possible of this ida root 21 see the 4 something la oido ja the 4 la kan the into 100 ka 465 la oidra ba see am summon gre have and arabo see o yaro have so the answer possible answer is 483 this is the approximate answer how's the yang zira yengzi swerum dana ko yang nam phadu jala so let's see root over 3 into 8.314 into 300 divided by bracket ka ya ho raha hai divided by 32 into 483.58 ఎంత రావా 483.58 హైగడ్రోస్ అఖోయినా సిదా హోట్ ఖిజా యామ్ లాబ్న మన్ బై ని షోర్ ngami si nata da mana sida 512 haira adi kamai toba sida 512 in iramadi 512 adi ka dotare thadok pitare na yam kupthan ho jaro ko sida not possible kak pabu yabro sibo direct kak yabro yam do mande ko sa yar good so the answer is option number a do erani question number 25 question number 25 jai ngating skip to ge smile to ge 26 one try 20 question number 26 try question number 26 question number 26 try question number 26 instead of 25 26 try karo RMS speed of a gas molecule is 300 meter per second calculate the RMS speed if the molecular weight is double and the temperature is half kitang thuno holo sidi question number 26 kay hay no mana RMS speed of a gas molecule is 300 ni hairava housing molecular weight to double hello temperature na half hello VRMS high was root over 3 RT by M na trosa sibu mana kayanen piba 300 meter per second sibu yarava then adudi anova VRMS o kya tani dias and irone anova VRMS formula irakpa kanda temperature do na kayo hello ba temperature has become half T by 2 mass na kya hello haba molar mass na double sina tro do mathak ki sigi 2 siga si makha da lejari 2 ani pulag 4 ta iroidra maka da 1 by 4 lani 1 by 4 do de koi 1 by 2 har ga root ma panda puto kya rava so it is 3 RT by m side kya ta hai root 3 RT by m de hana ge 300 na tro so the answer becomes 150 meter per second hai ga roja very simple si haira matung question number 30 ngasi ge last I think ngasi I di si topic si last after which we will discuss the last topic for which we will have some last questions try those try those question number 30 question number 30 question number 30 question number 30 RMS speed of oxygen is V at a particular temperature. If the temperature is double and oxygen molecules dissociate into oxygen atoms, the RMS speed becomes RMS speed kaya oirakadagi ha kya hoine haro same hoigedra oiroidra V RMS root over 3 RT by m na tarse for oxygen the oxygen dang hydridi O2 do not roja oxygen molecules to gidi V RMS high bazi root over 3 RT by dum iro m do kaya no oxygen gido 32 senator lay this 32 adu nagi sida kai oido ba gram ni into 10 to the power minus 3 kitang niyom sum ni easy yaro ba good sibu by question na b nian p banatro by question this value is b for nascent oxygen there is oxygen dissociate into oxygen kai da hage ba atoms ta so for oxygen atoms B RMS क्या था नहीं ड्यास ईरो रूट ओवर 3 R T to the mana कई दौरे हरा temperature is double have na throw twice T nascent oxygen O amak hakki di क्या था don हरो 16 into 10 to the power minus 3 now ani से ना ratio नहीं ना रही now direct si ubang si je sida sabang hairaga di kajuga ide sajira hanai film de tangai singe duga sigi 2 duma mapanda thamo 3 RT duma thamo adu sida 32 na to leidok jang 32 into 10 to the power minus 3 adu mi 16 dang leibadana 32 hapadi mathak da kai dom da ka oy 2 among hapte aroi dana 2 2 punjala di kya tare 4 root mapanda di twice la oidro twice 3 RT by 32 into 10 to the power minus 3 which is nothing but B comes double twice B I get to some na so ngasi ki last topic ma tharo Maxwell's law of equipartition energy kinetic theory of gas ta important oiriba B RMS puthokpa aduga amana energy ki matang da nahi na energy tharo Maxwell's equipartition से Maxwell's law of equipartition of energy Maxwell's law mana haise kaino hargadi ideal gas amagi hoina for an ideal gas energy puthoke tawkanda magi total energy se kaya ga mana ga dagi haradi ama namu yung ideal gas ideal khaki wana tana gas there is yam kuptha give yam piktha give particles ingidi potential energy have a gravitation potential energy mg kai h ka laite ko ja na makhoi energy di kari form da laido ba kinetic energy hoina yara bo sa kinetic and thermal adu thermal du kinetic hoina lakto ni random molecules random motion akoina energy have a kanda senagi degree of freedom have a term makhoi define tawdore don't worry define tawsala gas molecules ki magi each and every degree of freedom do have same energy we have for ideal gas each degree of freedom has same energy never and it is equals to half kBt see when appoint Maxwell's equipartition energy law has so hierarchy each nangi degree of freedom of an ideal gas has same energy and is equals to energy of 1 degree of freedom is half kBt where haraga kb is a Boltzmann constant kawi and it is equals to gas constant divided by Avogadro number n is Avogadro number khangni ko sa Avogadro number T is na absolute temperature in Kelvin ano sida yauri ba E sina kaino energy of each degree of freedom means 1 degree of freedom for 1 gas molecule na sida confusion pa मैम lai ri energy hangba kan sida man hayang total energy hangjale नत्रगा नगी ट्रांसलेशन का रोटेशन का गिनगी एनर्जी की रेशियो हंगे अमोंग ना मान हायरे 2 मोल्स हंगजिले अमोंग ना हायरे 2 ग्राम हायरे अमोंग ना हायरे 2 एटम्स हायरे सिदने माथा am सारे करी फॉर्मूला से ना दोइस ना फॉर्मूला तोंगान मोंग द फॉर्मूला से ई sometimes nagi in terms of r de ibaju thengna ne base half rt ga harga yara basa karam kanda karam basina dage hoi khangaji so basic sidagi khangawro degree of freedom amagi 1 degree of freedom for 1 gas atom or molecules atom oina leiba harga helium harga dima atom oina le modra madi molecule leite dana atai oxygen gumba hydrogen gumba harga kai hai doba molecules so for 1 gas molecule lerga na atom oina lerga na for 1 gas atom ideal gas wai doba degree of freedom amagi gas molecule amagi or atom amagi my energy is half kBt where kb is Boltzmann constant kauno ko sima mana hange hayeng oxygen gi hairadi kamai to amana nagi carbon dioxide gi hairadi kamai to natrega atotoba gas molecule se helium gi hairadi kamai to akoi sida degree of freedom kaya lay have the koi khangdi aroidana degree of freedom amagi nevzi for f degree of freedom gidi different forms of expression erasing for f of freedom and still one gas molecule or atom gas molecule amatang ohengo degree of freedom the f ohengo adi energy kama irane haro degree of freedom amamam gi silaire f degree of freedom gidi kya irane haro f by 2 kBt iroidro ja iroidro good kari umanang na hayeng n molecules haradi for n molecules for f degree of freedom and n gas molecules haradi gas molecule masing do n oiradi haro easy kariga manarni f by 2 sidi gas molecule amagi natra haji molecule kya sure n So n kbt n yaurakpadagidi expression je atopa mong am iba horaje mole concept sinerje haro number of moles kai ke mane haro mole concept mass by molar mass laire ay aduma sida sinaroi number divided by avogadro number hai daina number divided by avogadro number of the n haibaji kariga manare number of moles times avogadro number hai abraja of the once gas molecule masing khangak padagidi ay sumaine ithokpa yare capital n gi mahota n times n a kbt ive abraja ya bro n a kb ji kay mane ngasai boltzmann constant kamai define tawgi r by n a hai daina of the r haibaji n a times kb c oirodro ja so it is nothing but f by 2 n r t adon sida lai to sine endaraba yarabo and energy expressed in terms of r de iri to sini karam kanda no se gas molecules yaro kanda sida yaro n ji kaino haro what is this n number of moles for one mole gidi adum do shalamas if degree of freedom and one mole for one mole kya ताने दे सी इरेगा कोई न्यूमेरिकल हॉट हाउस final das my hero for f degree of freedom and nangi one moles kya ताने haro mole ama ka orega di energy is f by 2 and 1 orega dam natra rt ano nga sai f by 2 kbt oramedagi f by 2 rt do on gre sina kaya gino haro for one mole sigina for one gas yanda kadra good n moles ki definitely one mole ki c or n mole ki n multiply to roidro good sida su ire for n moles ki sida ire the degree of freedom hana khanga am to honaji then we can solve any question tharo next degree of freedom relation between degree of freedom and gamma exam da dizimba puzalu relation between degree of freedom f and gamma which is gamma havasina molar specific heat ki ratio do gamma have you know cp by cb adune ko hoji ido jan is a lot degree of freedom f have as 1 plus 2 by f ka be address mein ko gamma equals to 1 plus 2 by f ya karo sa gamma equals to 1 plus 2 by f gamma equals to 1 plus 2 by f si relation je mo khango now adu di ai hojik sumaina nangi table ama same aji sida koi type of gas ki type to erazi then sida degree of freedom is degree of freedom the sida translation sida rotation the total degree of freedom do now finally total degree of freedom c की according gamma की value क्या आता नहीं gamma have जाते क्या नते हैं cp by cb now let's see ahan badahiro type of gas था ऐसे कितने सहंदे आ रहे type of gas monoatomic थारो monoatomic example थारो example inert gas makai do helium, argon, neon. Yara was helium. Monoatomic oitar haro. Monoatomic had a point amakatani. Assumption is point amamam. Molecules or atom represents a point. Assumption of kinetic theory of gas. Point amase. Kaya pwede karam mong da maze move to yaga dage. Natraga maze race the lehen gede kamay thingbam da ka in how many ways it can move or in how many ways we can block this to keep it at rest. Motion lom doi nahi ji. Sige point sige mana move to yaga. Translation had it chumna sarpa. Rotation na teko ja. Every object kudima magi x axis ta y axis ta z axis ta pe yadro ja. So translation की degree of freedom had 3 because it can move in 3 independent direction x y and z यार बस यहाँ rotation दी point high target the point जी की ung बजे नंग any axis ocean होगा ung ब उगा दरो जाए सी point जी की ung बजे वो ungi कैसे खंगा दरो खंगो है point नमक की नगी rotation की degree of freedom had 0 total क्या तार है तो क्या translation की 3 rotation की 0 तो क्या तार है रो 3 what about gamma f to 3 since law क्या ताने हरो तो दी 5 by 3 so 4 monoatomic gases degree of freedom is 3 and the nagi gamma की value na 5 by 3 kauno ko sima good next diatomic or linear triatomic anisi zamani अब दे हारो से diatomic haradi example da say oxygen nitrogen hydrogen gas ayambana diatomic आतनी next linear triatomic haradi carbon dioxide even though polyatomic oizarazu kayo ida basa nang linear form da lebe linear da oxygen smile lerga carbon smile ka leida ne ja pitok pijing ka sana khara jo leida ne okay yare fare so linear oina leiravani na जब मानरने माई वैल्यू क्या ताने हरो सीधा हंदकती point ओइजरसु सुमाइन लेदो रे सुमाइन समझनरगा नाउ मूव तवजे कमाई मूव तवे यानी सेसी पेन जिने खलो मथा का खलो जुयाय देना सोम चलो जुयाय सोम द लाग पजु याद्रो से या ब्रो x सत पे याय y z पे याय z चलो जुयाय so degree of freedom for translation is always 3 rotation ददी rotation की degree of freedom हडी करंब मोंग द कया थोंग ना कोई उंग यागे हमने different ways क्या थोंग ना access to yengo sida akoina x axis harga si axis ama chingjal le harga si je any si chingjal le harga sum unga jo yadro jan we can rotate in this form haidi I x along the ai je chingjal le x high rabaina y gi axis ke about unga yaraba amana kamaina sumaina nangi manung da thinjele harga z axis lom the axis o helaga unga jo yadro jan two ways what about x lom the unga re si point ngak na dro jan point to sida thinjelaga sumai ung do ne je ung ang madra je bo puro have point ngak ni na yaraba point ngak ni na pitruk pitruk point ngak ni sai ga jang yam sound ye pe wani ana sumai ung ba je khoi kem khang am mo ung da bo gum ni ana ung ba se different axis ani thon ung ba yai x z ma y ma so degree of freedom for rotation will be 2 ne adi total kya tare haro 5 sida 5 se ladi 7 by 5 if nothing is mentioned in exam if nothing is mentioned about the type of gas use could take diatomic ni haina khallu haiba if kaim paramdraba then take the diatomic gas sibo yaraba ja ai point ang matang aire triatomic oitar gadi very important diagram last non linear non-linear triatomic, linear oidaba triatomic, or polyatomic. Polyatomic. Sure, example nangi methane CH4. Yar was ya. Sugumba oitargadi degree of freedom 3. Linear dadi adum 3 warni. Rotation the zohanati non-linear or mina 3 adum XYZ loin umba yare. Total degree of freedom kya tare 6. See 6 odi kya tani 2 ga 6 kakna di 1 by 3. Ado horen lasa kya tani haro 4 by 3. Sile sinjela tawang atani ko sa. But remember all this. Exam gyo na ningsang batamo ningsang. Yar bo si bawda? Yar good. Now adadi sida ko na hangdo ze. For oxygen, ratio of translation and rotational energy. Translation and rotation, kinetic energy. Kinetic se bracket quote ke 15 kinetic atani is high radi kamai to. Oxygen gas amagi translation ga kinetic ka gi mai ratio nahi no harade kamai ni. Maxwell's law na kari high energy have ji kamai igi haro F by 2 haro gas amagi logi ji अब जे कहिए मान के हरो K B T sinatra में natro then adudi energy translation divided by energy rotation high radi करिगे मान हरो yengo cha manaba temperature oide yaro mi same oxygen ki compare to natro temperature सब मान रहे kb कौन से निकलता नगरो करीदा depend तो ये दिया degree of freedom f translation divided by f rotation. Now tell me oxygen की diatomic की translation की degree of freedom क्या नो 3 rotation की degree of freedom क्या नो 2. So E translation by E rotation is 3 by 2. Hai kadra samana? Hai kadro? Be honest. Hai kadro? Still you are not honest. Yar was hai kadra was samana nangi ratio nahi no ka hara de. Now let's start solving some problems. Adu anga sige lokshala. Before we solve the last question ko, we will solve some questions. How is it? Last question. Hai do or the phag ta doga. Icham somebody houses hai. Question number 23. Question number 23. Ah, tama. Loidri luarani. Moi training lai bro sa. Ah. Ah. Ay. Hmm. Moi gari do kan ay ngatang lai su tora ge tamo. Okay, are. Now question number 33. Try question number 33. Question number 33. Question number 33. Page 47. So question ama ni hola ngasi ge swaida iloshange. Hayeng sigi mate question kara hola ge adogo we will be starting new topic. Yarava new topic se karam bo henje ge. Simple harmonic motion je dum takthara jira. Yarabo. So we will be discussing simple harmonic motion and wave. Question number 47. Question number 47 the high again. Ah. page 47 question number 33. Average kinetic energy of gas molecule at 20 degrees Celsius is her energy period. Ado magi average kinetic energy at temperature atopa amda putho ha matro. अब देखो ने energy habasdi kariga mana ba. So nangi F by 2 ga harone. Ado ka nangi KBT ga harone. Yara ba siya? Sine ko like this. Energy da. No ina sida R iresu kaisu kai de sina karigi form na no haro 4 1 molecules ki. Sida RT ha pura gana 4 1 moles. Ado kaisu kai de man di mana haji gas 4 okay sida gas molecule hare ko ja. So we'll be using this. RT irama bhauda kaido bai laloi doino hade khoi comparison tawdo neba same amount of gas same type of gas compare tawdo ne loi ka khirodra T khakta da depend tawne T khakta da depend tawne so energy depends on T khak oi bani na then haraga E2 by E1 high ready F si jo kaido do baharo degree of freedom ni mana gas molecule high kari gas on the khang da mene F khang dreba but still same gas compare taurine same gas ki F mana में लोई का खिरो इधरो करीदा depend तो होगा था के बसी T2 by T1 ला इधर में से वो the E2 क्या तारे हरो T2 by T1 times E1 T2 तो क्या नो temperature से करीदा on के दबा हरो Kelvin da so T2 is 227 have the Kelvin da क्या नो हरो 400 amma duna gaya 300 27 degree ni na sorry penuman parayam tan pi sina 227 okay amma 227 500 ade 273 2293 berani E1 di kya no haro 6.21 into 10 to the power minus 21 yam farak tan pi hai kak pa yabro sibo yaro ko ja adubo answer sing si am lap na brang na brengo 10.35 11.35 nagreda pare ka azi kay pailay 5525 5840.6 araba deda sibo di araba mana 10 to the power minus 20 si minus 21 ko ja power is the hongandre ko ja 10 ga 11 ga do power de minus 21 loi tham do roba adi horen last 0 ani si lakanda 621 habam lawidra 58.6 into 10 to the power minus 21 si di thuga ranu 50 na sida divide toropa kanda 10 ama 11 ama 11 yo yagadram te 58.62 nangi magi 11 oiram targdi 58 6 6 lairo 4 lairo 4 lairo 6 ade 644 nangi se digit ani kara kadaba IT4 58.6 digit am khatani si taragado inadro karigumba 11 oiruradia ai si kaido bai kupthano holino harga di answer si am nakna reba digit nangi masing of gadang 10 ga 11 ga ne so kya tane haro si 11 oiru yagadra sina sira divide over 11 gi di 644 yaw thokra ba in mathak the lady 621 11 di yawroi dana 11 yawroi so then answer si kya tare 11 di pick pam khallo which is 10.35 into 10 to the power minus 21 joule understand the words ya good calculation da kidang washalale okay yare nungai de sida thado khibadi question number 37 da thado kya so question number 37 sida su nungai 3 me 38 yare minute amma wali minute amma da question ani hochi question number 30 ga 7 do question 37 you know kya dara ha loss is sango now tharo question number 37 chap manavani ai calculation da kidang pen gi davani noi try to hai ni noi practice to hai ni 27 degrees Celsius the kinetic energy of an ideal gas is E1 higher. Temperature is increased to 327. Then kinetic energy will be E high basi we know F by 2 kBT. Karam kan sinobam ka hayo only for one gas molecule. F si de khoi kem khangdri ba. Adu tangai fadana numerical hot ke haradi diatomic lauraga F si 5 law doine ba. Ado hojik adu law rubagi su thoidokte maramdi ma is compare tawbani kangna jagrani dana. Then haraga do the E2 by E1 E reserve. E2 by E1. क्या ताने F by F कंगना करनी सेम गैस नहीं KB का खरे तो T2 by T1 ले हो रहा बा T2 तो क्या नो 327 डिग्री सेल्सियस 273 क्या तान है रो 600 ताबरा divided by 300 लाइट रोजा सीनेम नितंग दिशन E2 is twice of E1 यार अब जा good सीधा मंगा का थोलक तो नहीं 38 dictate or tozi average kinetic energy per mole of hydrogen at given temperature if oxygen का compare तो है hydrogen की mole अमा की energy का oxygen की कया का माना करता कि हमने mole अमा की energy compare तो है कहीं तो नहीं हारो हारो question number 38 compare तो इसे कहनो kinetic energy per mole है क्या नो for 1 mole ना तरजा of 1 mole of hydrogen atom लो molecule लो माहे जे hydrogen दंग हायरडी H2 क्या ताने हरो अतो का कना का compare तो बा kinetic energy of से जो per mole ngata ni so 1 mole of oxygen यार बा good value iro mole amamam gi energy kama you high haro half hydrogen gi F by 2 ni F by 2 haro mole gi di RT hai dane F2 hydrogen gi F kya no 5 degree of freedom 5 na grava because diatomic ni na andarava oxygen gi E gi hadi ma yuza manadro F by 2 RT natro degree of freedom for oxygen kya hoini 5 diatomic angta natra me 5 by 2 RT as temperature is same if the temperature is same energy will be still same that is kinetic energy of 1 mole of hydrogen ziga equals to kinetic energy of 1 mole of oxygen के समानी कई दो बहनों से माना इसे both are diatomic gas की type मानता रगदी temperature खगता depend तो हुई so energy is same अदे कई तारे हरो equals to that of oxygen है रजा यार fresh इधर लो चलेंगे सिगे नुई ना होने बा क्या ले रगा सु हयें बहुत ngairo हयें कंटिन्यू तौरसी सो हयें सिगी टॉपिक से मैं चौक पर लो चलगे आई ngasai hai ge bu kauraba assignment do kare assignment no लाइक पाव है बदु first नगी topic ओइना दुम यारोंगनी assumption for kinetic theory of gas अदुगी theory assumption खरि point मंगा मुक इसलो यारे लो चलस class सिदा की 1.5 hours की class ओयरनी को नखोगे because we don't have much time चलो